we've done in the past here, but we're going to do it with analytically. So not looking at a graph, but looking at a function. So again, really quickly, the thing we're going to look at today is these first two lines of the chart, where you get f of x and f prime of x. So this is kind of a condensed version of the chart. But if f is increasing, we can determine that by looking at if f prime is positive. If f is decreasing, we can determine that if f prime is negative. So if you go from an increasing function on f to a decreasing function, that is a relative maximum, and a decreasing function to an increasing function, that's a relative minimum. So remember, when there's a sign change, anytime there's a sign change on f prime is going to equal 0 when we have this happen. What that is all critical numbers. One second. All critical numbers are when f prime of x is equal to 0 or undefined. Again, if you get an undefined one, that's a sharp change in a graph. Pretty difficult when you have a function like a polynomial like the one on the screen. So you really aren't going to be worried about undefined unless there's an absolute value, piecewise function, maybe you have a graph. That's when you're really going to be determining when the critical numbers when f prime equals 0. Maybe the cases where you might get a fraction, you can get a denominator being 0. That might be another case, but not when you have a normal polynomial function. So on this particular question, it says find the intervals on which this function is increasing. So in order for f of x to be increasing, according to the chart, f prime of x needs to be positive. So what we got to do is we got to take the derivative first. So if f of x is equal to x cubed minus 10x squared minus 32x minus 34, if we differentiate that, f prime of x would equal 3x squared minus 20x minus 32. The key on this one is we're going to have to factor this. Now this isn't a really easy factorable one. I wish I'd picked an easier one because this one's not so easy, but I'm going to go through it anyway. Because what we want to know is we want to know when 3x squared minus 20x minus 32 is equal to 0. That's what we want to determine. When that happens, that's when we potentially would have a sign change. So what we want to do is we want to factor this. Now there's a lot of ways to factor this. Hopefully you remember how to factor. I just saw a recent video of factoring, and maybe I'll put that in this. And it was a pretty slick way to do the factoring. But admittedly, I didn't watch it enough to memorize it. So what I'm going to go back is to my bias. My bias is to know that we have 3x here and x there because that's the only way we can get x 3x squared out of the first terms. Now we got to do the last one, and what we have to do is we have to somehow get this to be get factors of 32. Now we know 32 can be divided by 4, and you can get 8, so 8 times. So that's probably where I'm going to go. Is normally I'm going to pick that middle one. So that's the one I'm going to do. If you need help on factoring, go back to one of the first videos that we ever did. We talked about factoring, but here we go. If I know that if I make this one 8, and this one 4, I'm in pretty good shape because 3 times 8 is 24. Subtract 4 or subtract or add 4 more, you'll get 20. We need this one to be negative and this one to be positive. Now, what we need to do now is we need to figure out where are these critical numbers? Where are these factors? Where is this derivative equal to 0? Well, that's when 3x plus 4 equals 0 and when x minus 8 equals 0. So that's when x is equal to negative 4/3 and when x is equal to 8. Now, the good thing I have on this is what I'm looking for now is I have some parameters. Those two things are critical numbers. Negative 4/3 and 8 are my two critical numbers. And I have some parameters to work with. So what I like to do now is I like to make a table. I like to make a little chart. And other teachers will do this a lot of different ways. But what I like to do is I like to do this. I like to say x is equal to negative 4/3 and x is equal to 8. And what I need to do is I need to pick some sort of a test value. And I need to test on f prime. And I want to test a value to the left and to the right of negative 4/3. And I want to test a value to the left and to the right of 8. Well, one of the easiest test values to pick right out of the gate is 0, because 0 is just to the left, is in between negative 4/3 and 8. I'm also going to pick 9 over here. You want to pick numbers that are easy to do. Negative 4/3 is 1 1/3. So if I pick negative 2 here, now what we're going to test those on is we're going to test them on f prime. And we really want to know when we test these x values, we want to know is f prime positive or negative? Well, there's our derivative. Okay, there's our derivative. If we put in negative 2, we do 3 times negative 2 squared. And we multiply it, and we do, so that's going to be a positive value. And so, and again, I'm going right into the derivative. So let me just write this out for you. I'm going to write it small because I want to see everything. So I do 3 times negative 2 squared minus 20 times negative 2 minus 32. If you think about what that value is, you should clearly see that that is a positive quantity. When we put negative 2 in, we get a positive quantity. Now let's scroll out again and look what happens when we plug in 0. If we plug in 0 into this, notice plugging in 0, we get negative 32. So when we plug in 0, we get a negative quantity for f prime. When we plug in 9, if you look up there, plug in 9, 3 times 9 squared, minus 20 times 9. We could put that into our calculator just to make sure. So if I did, 9 squared times 3, minus 180 minus 32. What I think I'm going to get is I'm going to get a positive value because 9 squared is such a big number. So this is a positive value. What I've determined is that f prime goes from positive to negative at x equals negative 4/3. F prime goes from negative to positive at 8. So if f prime is doing that, then remember that f, according to the chart, must be going from increasing to decreasing to increasing. Okay? So f is going from increasing to decreasing to increasing. Now it's doing it at these critical numbers. That's when it's doing it, at these x critical numbers. So if I need to determine what intervals on which this function is increasing or decreasing, in this case increasing, what I'm going to do is I'm going to go, okay, I'm going to use open brackets also. I'm going to see what Delta Math says on this, but I'm going to use open brackets. It may end up saying that, well, let me just try it. So I know I'm going to go from negative infinity all the way up to negative 4/3. But I need another interval because I need another interval increasing. So I'm going to hit that plus sign, gets me another interval. And now I'm going to do another interval, but I'm going to do 8 to infinity. Let's see what that tells us. See, they may not like my, oh good, they liked my, that I didn't include those. But all I did was I did the same thing they did. Got the zeros, and then they did a sign chart. They did a sign chart a little bit different than mine. It's the same kind of idea. And then they went further to say, here's what the graph actually looks like. So check that out. And that's our value. Let me do another one. You can stop the video and try one on your own now if you're feeling comfortable. But let me just do another one. And let me think about, let's do this one. This will be a good one. So this one is asking for the relative maximums. So now for a relative maximum, you need to think, oh, that's when for a relative maximum, that's when we're getting a peak. That's when f is going from increasing to decreasing. That's when f prime is going from positive to negative. So that's what we're looking for. Well, in order to do that, we really need to figure out what f prime is on this. So let me zoom this out a little bit so we get a clear picture. So if f of x is equal to x to the fourth minus 12x cubed minus 29, and I find f prime of x. F prime of x in this case is equal to 4x cubed minus 3 times 12 is 36x squared. Now, when you think about what you got here, is we got to factor this, right? Because we got to figure out when is this equal to 0. So we're going to need to factor this. Well, we can pull out a 4x squared on this. And what we have is we have x here, and 4 goes into 36 9 times, and that equals 0. So our critical numbers are when x equals 0 and when x equals 9. These are our critical numbers. So if those are our critical numbers, then here's what we're going to do with them. We're going to set up this testing thing. We're going to set up 0 here. We're going to set up 9 over here. And we have to have a test value. Okay? We have a test value. Now, let's think about what we're going to test. We're going to test something on this side. We're going to test something on this side. Something in between those two, really. Well, let's pick some really easy values. Let's pick -1 here. That's a really easy value to use. Let's pick 1 in between 0 and 9. And let's pick 10 here. You want to pick nice, easy values. And now what you really want to look for is what is the sign of f prime. So there's f prime. Let's think about what happens when we put in a -1. When we put in a -1, we get if we think about it, if I actually did it, it would be 4 times negative 1 cubed minus 36 times negative 1 squared. Think about what that is. That is clearly a negative value. That is clearly a negative value. If we go in here and we put in 1, and subsequently you could put it into the factor derivative if you wanted to. We could put in 4 times 1 squared, 1 minus 9, and see that that there is also a negative value. We could see that that's a negative value. And then finally, if I put 10 in, 4 times 10 squared times 10 minus 9, that's a positive value. And if I'm looking for the relative maximums, I never get a place where f goes from positive to negative, only negative to positive. So I don't think there are any. And I'm going to submit the empty set. And notice, I was pausing there for a second to see whether I had done something wrong because I didn't get a relative maximum. Notice f, there's no sign change. Here. And over here, so when x equals 0, there's no sign change. When x equals 9, f prime goes from negative to positive. So f has a relative minimum here, but no relative maximum, and that was what the question asked for. So that's where I was pausing for a second because I was confused to see if I had done anything wrong, but there's the answer. Again, we're going through there. Make sure that you review these, and I can do more examples if you're in need. Thank you. Have a good day.